Hello, everyone. Welcome to Fanfest 2025. Anyone here for the first time? Yes. Ah, that's a lot of you. Anyone who was here in 2023? Anyone who has seen my presentation in 2023? Nice. So we'll know a little bit of what we're talking about. For those of you who haven't seen me before, my name is CCP Aporia. I'm a principal engineer on CCP's platform segment, and I have over 20 years of industry experience, more than 10 of that at CCP. I started my journey in video game development working on action role-playing games. This is from the Sacred Underworld add-on, which was the first project I worked on. And one of the last big project at CCP I worked on was getting EVE Online natively onto macOS, which entailed the first steps into the direction of extracting our Carbon engine from EVE Online. What is Carbon? Carbon is our internal game engine that we build to run EVE Online and also use now to run EVE Frontier. It is extracted from the game because initially the focus was just, let's make a cool game about spaceships in space. And getting it into an engine was then, well, extracting the engine was a bit of an afterthought. But this is normal, it happens a lot with game development. It is optimized for large-scale, massive multiplayer real-time strategy games, which EVE is. So you won't be able to see any fast-paced Counter-Strike-like games or anything. Like, we are focusing on delivering 10,000 player fleet fights, not on getting you 120 frames per second running around with a gun. Last but not least, and this is important, it is built on top of the Python programming language. In fact, up until very recently, it was built on top of stackless Python version 2.71, which at this point is about 18 years old. So we decided to upgrade Carbon to Python 3. And it's a huge project. You can see here the amount of code that we had to touch. It's about 4 million lines of Python code, about 1 million lines of C++ code, and that kind of makes it the biggest project CCP has ever done engineering-wise, apart from creating EVE Online itself in the first place. Given that sheer size, it's also the riskiest project that CCP has ever done. What you see here is, for those of you who have been at the south coast of Iceland, this is the warning sign that is put up at Reynisfjara Beach, which is a very beautiful, but also very treacherous beach. And just like with projects, there are different levels of risk. When the weather is green, or when the weather is good, and the green light is on, you can basically go almost wherever you want to. Just don't go into the water, that's dangerous. When the weather is not so good, the yellow sign comes on, or the yellow warning light comes on, and there are some areas where you shouldn't go. And when the red light is on, then you maybe sometimes can't even park your car there, because the car park might be flooded. And in this case, this project, upgrading Carbon to Python 3, was definitely in the ballpark of a red warning light. Given the amount of code we had to touch, this touched basically everything. Not just the game itself, it touched the build pipeline around the game, it touched all the developer tooling that we had to provide, and many, many more little things along the way. So when it's such a big and high-risk project, why do we even want to do this in the first place? Well, this picture kind of sums it up, right? We have this nice little game, EVE Online, and we have this kind of vital cornerstone of Python 2.7 down there. Well, stackless Python 2.7.1, right? Not Python 2.7 itself. And it's kind of a problem because, well, it was kind of a problem because Python itself was deprecated in January 2020. That's like more than 5 years ago, right? We knew this was coming and could prepare a little bit, but this definitely was a sign for us, okay, if we want to stick with Python as a vital technology, we have to make some decisions. And one of the side effects of Python 7 having been deprecated 5 years ago, and it had the deprecation having been announced like way more than 5 years ago, like probably like 15 years ago at this point, many of the new hires we hired into CCP didn't even really have Python 2 experience. They were used to all the nice features in Python 3, but it was a bit of a shock to like not just having to use Python 2, but then also stackless Python 2, which is yet a little bit different from normal Python. The next thing, and this is something we learned very painfully during the native macOS client work, is that Python 2 has very limited platform support. Apple released the new silicon chips a few years ago, which is an ARM64 architecture, and Python 2 has no knowledge of that, absolutely none. We were a bit fortunate that there's this Greenlit project in the Python ecosystem that did work to get Greenlit to run on the ARM64 architecture, and we could then backport some of the changes they made into stackless, so we could get running on the silicon chips, but it took a bit of effort, way more than it should have. And it's very risky because you don't know if you backported everything correctly until sometime later. The ecosystem has moved on, right? It's like we are using quite a few external libraries in our development environment, and a lot of them are basically like, yeah, this next major version drops support for Python lower than 3.6 or whatever. And it's like, okay, what do we do? What do we do if we want to go further? Do we want to write all these libraries ourselves? Do we contribute to all of those libraries? Do we have the manpower to do all of that? Probably not, because we are a company of 450 people, and there's an ecosystem of millions of people, right? It's difficult for us to keep up with this. And one thing that was very interesting to us is that with a lot of the changes that were done in Python 3, we could remove a lot of modifications that we made to the Python interpreter itself. Carbon, being built on top of the Python programming language, used to contain a lot of modifications of the Python interpreter to deal with things like Unicode on Windows, because in Python 2 this was more or less an afterthought. Those of you who play in Russian or Korean or some other non-Latin language will have learned this every now and then. Things break, and this is because Python 2 was not that good at dealing with those scenarios, and we may not always have been great at considering all the edge cases there. But in Python 3, a lot of these things just are solved, and we get this kind of for free. This makes maintenance for us easier. We can focus more on getting those 10,000 player fleet fights, as opposed to, do we have support on all file systems? So we had to make the decision on how to proceed. We decided to upgrade to Python 3, and it's a huge project, and we need a plan. What's the best way to approach these sorts of large projects? Well, you can look at Mother Nature and go like divide and conquer, right? Evolution has proven this strategy works beautifully. You divide the problem into smaller problems, and that way you solve every small problem one at a time, and eventually the huge whole will come together, and it works. This manifested in a plan overview like this. This is actually from relatively late in our development cycle for Python 3, and it was CCP Eamon who was sitting here that actually turned my ugly developer schematics into like a more beautiful picture of where we're at. And the divide and conquer approach, you can see here that we split it into like into two different tracks. The upper track is dealing with those 4 million lines of Python code. Here we partnered with an external partner called Reckon Digital that did a lot of the groundwork on that front. There's a second split that kind of goes through here, because we first wanted to make sure that the Python code base still runs with Python 2 as well. The Python ecosystem gives us like an option to have source code compatibility between 2 and 3 to a large degree. And this is what we first did. So we get some experience there, see if we break some fundamental game features by just going from 2 to 3 in the Python code world. And then later on, we decided to, okay, let's go all in on Python 3 only. The lower track is our C++ code base. There's a tiny two-split here. The first one was, can we get the stackless Python builds for Python 3 going in our environment? Like, there's a lot of minor detail that we need to pay attention to as well. And then we have all of the different engine components that we needed to port over that we kind of took as small milestones to go through. And then some bigger milestones towards the end, like getting the server and proxy running, getting the client running, and so on. This plan was then executed. Here's a timeline from 2023, when we were at the beginning. So here about is the picture that I just showed you was created around here. We officially kicked off the project in May, but I took a look at the commit history, and the first commit we made for Python 3 compatibility was in February 23. So it actually precedes the planning itself. It was just like a small experiment to see whether we can do it. One more thing you can see on this plan is like the various different milestones that we set ourselves and for the stakeholders in the project to see progress that we have. Important thing to note here is that we wanted to have the server running first in the Python 3 branch because the server needs less of the engine components than the client does. Like, we don't need a graphics engine, we don't need the audio engine on the server. We do have a database driver on the server, but that's tiny compared to these other two modules. So you can see that this plan accounted for a lot of spare time or a lot of downtime. Like, I like to compare this a little bit with like building a rocket. You know, it's like it takes time to build a rocket, to figure out how all the pieces need to come together. And then eventually, once everything is attached to it, you can try to take off, and that was basically around here. So, to our own surprise, this plan worked out better than expected. Like, Reckon Digital was done with the Python code conversion after like 2 months or so, and then we were behind a bit on the C++ front at that point in time, so there were a lot of small successes. And eventually, then this was a bit later than the initial plan that I just showed you said. Like, this was November 1st. This is our server starting up. And we were like, yes, server runs on Python 3. Great. Awesome to see. Same day, this is the client, the login screen. No, not a lot of graphics, but a little bit of UI, right? And we were super happy, except it crashed right away, right? Like, okay, like, hey, I get to see it for like 10 seconds, and it just, bam, explodes in your face. But then November 9th, just a week later, basically, we have graphics rendering. And we are trying to log in, but the connection failed. Server and client didn't want to connect. I was like, okay, there are more things that get initialized lazily in the background once you start logging in. So yeah, okay, there's more stuff that we need to fix up. All good. We still consider it a big success. And then November 17, login complete. Yes, middle of November, we are there, we can log in. Great, we're Python 3, right? Can we play? Well, networking is hard. It started out with our QA finding the same day when we tried to log in saying like, hey, the proxy freezes when we try to connect to chat. Like, okay, we didn't try to connect to chat before logging in because you need to be logged into chat. What might be going on there? Let's look at the logs. Plenty of warnings about like unclosed sockets. For those that don't know, a socket is essentially like a mail address that computers use to talk to each other. And they really shouldn't be not closed when you're done using them. You have to close them. There's only so many that the computer will give you before it says, like, I have no more. So that was already like, hey, what is going on here? And then not just warnings, but also errors showed up in the logs. Well, shit. Right? This was us sweating quite a bit because the networking stack in EVE Online is a bit special. We had, like, in order to support thousands of you playing in a solar system, we have to do some magic underneath the hood. And we realized then that we need a new network module for Python 3. What you see here is a short schematic of how our old network module stack looked like. At the top, we have the Python standard library modules for secure socket communication, the socket itself, and select. And this was all built on top of our customizations that we did to the standard library and the Python interpreter itself. And we had two implementations, one being KQ, which is used on macOS, one being IOCP, which is a Windows-only technology. And this is how it was built back then. Like, this is 15 years old or 16 years old that we ended up writing this. Like, you may remember the big stackless.io blog post back in 2009 or 2010. One problem that we experienced with the Python 3 update is, well, okay, we experienced it before, but this old network stack that we had only supported TCP communication. It's okay for playing EVE Online. It's not so great when you try to do more advanced things. This has given us a bit of a headache already in the Python 2 world when we tried to do some new things in our server infrastructure, which wanted to use UDP, and then it didn't work. And as I mentioned, like, this is all based on a lot of modifications to Python's source code and the standard library so that we get it to work. This was not the way we could continue doing things because of the way that Python changed these modules between 2 and 3. So we need to write a new network module. And we decided to build it onto Unicorn Velociraptor, or LibUV. Yes, that is a Unicorn Velociraptor. I was a bit surprised. But effectively, the old custom low-level implementations we had, which predated the existence of LibUV, they were of varying quality. They had their own little bugs here and there, limited support, as I said, only TCP. LibUV basically gives us support for everything we wanted out of the box. It gives us cross-platform capabilities out of the box and made the life a lot easier. So we decided, okay, if we have to touch all of this network module anyway, let's modernize it at the same time, and let's bring LibUV into the equation. And the big thing that it gave us as well is that we no longer had to modify the Python interpreter. We have drop-in modules that we place in the environment instead. So you still use the standard library, but underneath the hood, the binary part of it is just a drop-in thing that we do, and it makes so many things a lot simpler. Great, right? So we resolved our network issues that way, and we're very confident that the project was going really well. But as I said, this is November 2023. And Stackless Python version 3 that we upgraded to is Stackless Python 3.8.1. Now, those of you who follow the Python ecosystem will know that Python 3.8 was officially deprecated in 2024, November 2024. So we decided, let's pivot. Let's go all the way 3.12, right? We were aware we had to do this, and we just said, let's fast track this. Unfortunately, this had some side effects because Stackless Python is stuck on version 3.8.1. This was a bittersweet moment for us because it meant saying goodbye to an old friend. For a long time, CCP has been helping a lot with the maintenance of Stackless Python. And it served us really well because of the unique way it approached asynchronous programming in the Python ecosystem with the concept of tasklets, or also known as greenlets these days. And we had to come up with a solution. What do we do? There are many different things that we investigated. And we decided to write a new scheduling system on top of Greenlet. And those of you who are curious, there's a talk tomorrow by my colleagues CCP Tobol and CCP Cookies, which talk exactly about the journey they had to take to get a scheduler for Greenlets with Python 3.12 that suits our special demands on the source code. So we were upgrading, and it was a bit again like building that rocket. You know, took a few months now to get from the initial success we had with Python 3.8 to success with Python 3.12. This is June 13th, 2024. My colleague CCP Rave posted this in our Slack channel, said like, first? We were like, wow, great, that's Python 3.12.3. Like, we're in space. And this time it only took us like 5-ish months as opposed to like the 8 months before. Great, right? Ship it? We're in space? Almost. At this point, we decided, let's give this to Eve Frontier. Let's see what happens, right? Because this was like, we did most of the work with Eve Frontier since they were the new project. And it was a bit easier for us to get the changes into there. And all right, let's run a playtest. That's the graph of concurrent connected users that we had in the playtest. This is not what it should look like. We released we opened the floodgates, and very quickly we noticed that about every 15 minutes a solenoid was dying, or rather locking up, which meant it missed its heartbeat, which meant the cluster said like, oh, that node is dead, I'm gonna remove it. Some people got disconnected, but that then just had a nice trickle-on effect, and everyone kept getting disconnected the whole time. So we had to restart the server like every hour. Not great, absolutely not. And we were a bit like, okay, what did we do? Why is it so bad? We had an internal playtest with exactly the same thing, with exactly the same version before, and that worked flawlessly. Well, it turns out there was a legacy system that is not actually used by Eve Frontier. It just happens to exist still in the code base and happens to still be active to some degree. It happens to be a queue. And as queues go, eventually they are full if nobody's consuming them. And when they are full, they're basically telling everyone who's trying to write into them, like, stop, you have to wait. And that's why we locked up. Once we discovered this, props to CCP Habakkuk, who actually found this out, or discovered that this was the root cause. It was like a trivial fix, but those were a few days where we were very stressed, and because so many things had changed in the whole journey, we were a bit like, what is it? Where can we find it? But success. Eve Frontier is running on Python 3.12. Now that we are running on 3.12, was it worth it? Was this journey worth it? What do we gain from it? For starters, we gain better observability. We used to have, a common problem that you have when you're writing software is that you end up leaking resources somehow. For example, memory, right? You say I need 8 megabytes of memory, and then you just keep saying like I need 8 more and 8 more and 8 more, and you think you're also returning those 8 eventually back to your operating system, but you're not. And there are various tools at your disposal if you want to track this down in a language like C++, and it's relatively straightforward. But when you're trying to pinpoint this in Python, it's very difficult. We had some in-house tooling, but this was very clunky to use as well, and was not really giving us a concrete place of saying, like, this is where it leaks. It was more like, well, it's these type of objects that are leaking. So you may probably want to check, like, where are those created, and then go ahead and investigate every single location. Is this dealt with correctly here or not? And, well, it was very clunky. But in Python 3.4, a new module was added to the standard library called tracemalloc. And tracemalloc actually tells you exactly the line of the Python code that allocated the memory. So when we did another round of playtests for Eve Frontier, we saw that on the proxies, the memory was ramping up way quicker than it should, right? It didn't help that Frontier didn't have a downtime, but like it should never go up from the initial 2 gigabytes to, it's like 13 or 14 gigabytes here. And that pattern just kept repeating. So we restarted the cluster and we saw the instant rise again. We instrumented the code, or one of the proxies rather, with this tracemalloc module. And within 15 minutes, we had fixed the memory leak. Like at this point, we instrumented. We discovered and made a fix on the 17th here. The deployment was on the 19th, and we saw, yep, this looks a lot better. Yes, there is still growth, but that is just a lot of internal caching that we're doing, and caching obviously eats into your memory persistently up until a certain ceiling. And this is one of the big benefits then we got from Python 3.12. Like the tooling around it to understand what's going on in your software got a lot better, and this helped us a lot. Another thing is we see improved performance. You can bring more ships into space. You can fire more guns. CCP Habakkuk spent some good time getting some of the existing benchmarks that we had into a new visualization dashboard. What you see here is basically the rendering tests that we have, where like these are all Python 2 things. It's just for demonstrating the visualization. But like he basically set up a lot of those dashboards, which are super useful because he also added then some smaller tests that specifically focus on Python. These are micro benchmarks. And what you see here on each side is like 4 different test cases, where the top 2 entries are the Python 2 version, and the lower 2 entries, the Python 3 version, right? Looks good. Python 2, Python 3. Python 2, Python 3. Python 2, Python 3. Python 2. Wait, what? What's going on? Well, actually, this is a fluke. What we see here is the behavior that, like the Python 3 behavior here is the same that we also see in Python 2 on macOS. The difference that exists in this specific test is just that in Python 2, there was a tiny optimization made on the Windows side of memory allocation that made it a bit faster. But macOS always behaved like this. So in the grand scheme of things, this being micro benchmarks, the grand scheme of things just meant like it didn't matter. Like, yes, those memory allocations are a bit slower, but we're not allocating constantly. Like, you shouldn't be allocating constantly. So in practice, while there is a perceived regression on this one micro benchmark, overall, the performance increased by about 20% on average, which is a really big gain. One more big update or benefit of the update is that we clearly now can upgrade to more newer versions of Python 3, which means we will be benefiting from bug fixes that are being pushed out, right? Let's say with this Unicode support I mentioned earlier, if Python releases an updated Unicode integration, we can now update our version of Python and we get these fixes for free. We don't have to like try to figure out ourselves on how to get this into our custom interpreter, especially in Python 2. There are many performance improvements that are happening to Python 3 at the moment. About a year and a half ago, the CPython community started a project called Faster CPython, where Guido van Rossum, the creator of Python, assembled a few people saying they wanted to improve performance by multiple percent. I think it was 20%, 30% over the course of the next 4 years. And some of these improvements are already in Python 3.12. Not much. I think it's like a 5% improvement compared to the baseline of Python 3.6, but there is some. And one very exciting thing that we're looking forward to is that there is work going on to remove something that's called the global interpreter lock. Now, what is this global interpreter lock? Effectively, when you have a shared resource and you have multiple people trying, or multiple parts of your software trying to access this shared resource, you need to coordinate access to it. In Python, the memory is the shared resource. Your whole Python program lives on the heap, and everything that you do in your source code tries to access potentially the same thing in the heap. So Python has this global interpreter lock that basically every time you modify a Python object checks like, can I actually do this? Do I have to wait for someone else to complete their business? Or, and so on. That is very costly. And we have seen this in our own benchmarks back in 2010 already, that this is one of our main contention points when it comes towards optimizing our network stack, optimizing some parts of the rendering engine and so on, where this bit of waiting on the global interpreter lock is critical latency for us. So we're really, really excited to see this work happening and then being able to start trying it out. That said, at the moment, the implementation that exists in Python 3.13 is actually slower than having the global interpreter lock. So we are still a bit waiting for what's happening there. But the important bit is, thanks to the upgrade to Python 3, is we can go and try it out whenever we want to, because we are on the same level of modernization as the rest of the Python ecosystem. Great, right? I said it's on EVE Frontier, but this is EVE Fanfest, which was started for EVE Online, so a lot of you will probably ask, like, when is EVE Online going to run on Python 3? Because right now it's still on stackless Python 2.7.1. Well, EVE is a bit of a different beast, right? Like, it's a live game for starters. So while with Frontier, you heard me saying before, like, yeah, and then we tucked on the servers, and we deployed a new version, and so on and so forth. That's a bit more difficult for EVE. Like with EVE, we cannot have like a downtime of multiple days or something. You guys want to play. We want you to play as well. And so we need to figure out a good way that we can gradually roll out the changes to EVE, so that we don't have to do like a wholesale everything Python 3 right away. And yeah, this is kind of critical. Why is this critical? Well, primarily because EVE has a lot of history, a lot. You guys have been playing for well over 20 years, and all of that stuff is persisted in this universe. EVE forever, right? We want to have EVE running for like decades or centuries to come. Unfortunately, some of this history contains data that is not quite that easily transferred over to Python 3. And so we need to figure out some solutions to that problem space first. And last but not least, I said we built a rocket. Well, it's like building a rocket. And we know the rocket can take off. But so far, it's been taking off in the Frontier playtests. And they are comparatively small compared to the load that EVE Online sees. So yes, we know the rocket takes off, but can it take off of the load that EVE Online will bring? And we need to figure this out as well. So there are some complications in order to get Python 3 version of Carbon into EVE Online. The good news is we have a plan. It is a tentative plan, adjusted towards the specific needs. There are some steps that overlap with what we did for Frontier and Carbon in general, which is basically these first two items here. And to some degree, then, this is the third item. But the big chunk will then be like the later phases where we have to go and figure out how can we deploy. Can we maybe roll out on a subset of the proxy nodes first? Can we roll out on a lowly loaded solar system first, right? So that if things go wrong, which we hope they don't, but if they go wrong, the impact will be very limited for you. And yeah, the timelines here are just up in the air completely. Like there's no promise when it will be done other than soon, TM. And with that being said, any questions?
Can you actually upgrade to new Python without breaking the postcode?
That is a great question. Possibly, yes. I'm not aware of the plans for the postcode.
Oh, so there are some plans to get rid of it? Finally?
I don't know.
Okay, thank you.
Would it be easier for you guys to roll it out in one motion? And would you be willing to like survey the player base? I mean, we might be open to that if it's more reliable to roll it out over multiple days of downtime.
It is one of the things we're discussing internally. Like, for example, for the client, it could be that we just roll out the client wholesale to everyone, right? That this runs on Python 3 right away. There's a lot less risk on the client side than there is on rolling out the servers in Python 3. Mostly because, yes, it's going to be terrible if someone will have a problem with the Python 3 client, but we can provide options there to fall back to a Python 2 client, if need be. With the server, it's a bit more difficult. So the big problem really is like if we wholesale upgrade all the servers to Python 3 right away and all the proxies right away, like it will affect everyone who is playing at that time. So it could be that nobody can play for a while until we roll back. Or it can be that we start seeing such a weird performance profile in the cluster that it's getting really difficult to like pinpoint where is this coming from.
Will this bring the tick rate like in a Frontier on your line, like half a second?
So we are investigating it. Frontier is taking a bit of a lead on that front, but like the simulation between Frontier and EVE Online works differently, right? They're different games, so like we need to figure it out, basically. But it's definitely somewhere on the long-term list for us to investigate.
Why did it take so long to like upgrade to? Because it's just like you already had a deadline to like it's gonna be discontinued. Just asking, is it just laziness or?
Great question. It's a question of priorities, right?
Yeah.
I mean, we had a perfectly running game. Well, more or less perfectly, I suppose, but like you were all happy playing, so it was running. And there's always a question where you need to balance, like, do you want to do such a massive disruptive project now, or do you want to see, like, whether you can do like parts of that project along the way already? Like, for example, we were discussing doing this before we did the native Mac client. But it turned out that a lot of the things that we had to do for a native Mac client actually make it easier for us to eventually do an upgrade from 2 to 3. So it's a bit of like you always look at the steps you have to take. And then you try to align the path that you need to go with like the business needs. And then it's just a case of priorities.
With these changes and moving over to standardization of a lot less customizations that obviously allow you to move to macOS and whatnot, is there any intentions to perhaps natively support Linux or something like that?
Linux has come up before. It's not on the roadmap. There are some peculiarities to Linux, because Linux itself, yes, there's the POSIX standard that also affects macOS, but when you look at the larger environment, like the amount of different desktop environments, the quality of graphics drivers, sound drivers, network drivers, and so on, it has matured a lot, right? I run a Linux machine at home myself, but it's from a business perspective, a lot harder to justify at the moment, I want to say, so it's not anywhere on a priority list to support Linux. Maybe. Maybe it's already running on SteamOS.
Was there ever a serious consideration to use a programming language other than Python?
Yes. We had one of the first meetings back in late 2018, I want to say. We were looking at this problem, right? We were like, okay, Python 2 is a dead end. As I said, like we were aware of it for a while, that we need to figure out a solution for this. And one of the things that was actually entertained was like, can we port everything to Unreal Engine? What would it take? But like once you get some of the first numbers on your code base, like as you've seen, 4 million lines of Python code, test coverage, the amount of C++ code, the way the rendering has to behave, and so on, like completely getting away from Python was thrown out the window quite quickly, because it's just like this took us the better part of 2 years. Rewriting everything in a different engine, be it in-house or external, would easily double that, given the amount of history that EVE Online has.
As you previously mentioned, CCP was probably the largest user of Stackless Python. Is there another major contributor to that project stepping up to take CCP's place on maintenance of that, or is it essentially dead from that?
in fact, the Stackless Python project has been archived in February this year. Like the maintainers put up a notice saying like it's no longer maintained. And it's a bit sad to see, right? Like served us very well, but due to the changes internal to Python between 3.8 and 3.9 and 3.10, it was like the effort just became too big. So I'm not aware if anyone is trying to maintain Stackless Python, but there are many different like options in the ecosystem, right? Like Python itself has the async IO module built in. You have G-Event, which is built on top of Greenlet. You have, I think, Twisted and Tornado are still there as well. So like you have options.
What part of the code base do you enjoy working on the most, and what part do you enjoy working on the least?
Can I plead the fifth? No, I think there's no part where I would say that this is the most or least enjoyable. Like every part has its own little like delicacies to some degree. Like sometimes it can get a bit confusing because of the way that we need to bootstrap everything, because we are still an embedded customized Python interpreter, just not Python itself being customized. So you know, there are occasionally some moments where you go a bit in circles to unravel something, but like there's nothing that is really terrible to work in or exceptionally great to work in, right? There's a like. Most proud of? Personally, I want to say the new network module because I was very involved in that. But I'm also very proud of what CCP cookies and CCP toolballs did with the scheduler. Like I think these two new modules, like maybe that's a good answer to your question. The new modules definitely could benefit from a lot of like greenfield development, which allowed us to do a lot more modern practices right from the get-go, as opposed to having to convert a lot of things to those modern practices first.
Do you plan to roll out the Python 3 upgrade for EVE Online on the Singularity server first, or is that running on the same infrastructure, so it's not possible?
It would certainly be rolled out on a test server first. But again, the exact details are still to be decided, and we'll see. It's probably going to hit Singularity at one point, because everything is supposed to hit Singularity before it goes live, right? So. Yeah. All right, we got 2.5 more minutes.
You talked a lot about how you are converting to Python 3, but have you also been thinking about how to future-proof that for the game that's going to be running for another 100 years?
Yes, absolutely. So first of all, we don't anticipate that there will be a Python 4. Like the Python developers themselves say, they're not going to do a big change like they did from 2 to 3 again, because it almost killed the language and ecosystem, in their own words. I think they were just saved by the amount of data scientists that had started using Python. And I mean, you can see it also by like how long it took like a lot of the Linux distributions and then macOS to basically stop having a Python 2 version by default, right? When you run Python scripts. But aside from that, we do anticipate now that we have to do a lot more updates, right? We want to, like when it gets to EVE, for example, we don't want to ship 3.12.3 to EVE. Like I think we had 3.12.5 or so right now, we had 3.13 already. Like 3.12 is at 3.12.5, but like 3.13 is out already, and September this year or October this year, I think, is 3.14 release planned. What we have done is that we essentially optimized our pipelines and the way that Python gets included in the build to a degree that it's now a case for us. We just change like the tag from the Git repository we want to check out. Before, this was like a lot more complicated, a lot. So yeah, we definitely have taken quite some steps there. Yeah. 50 seconds, anyone?
How does Python 3 change your plans for open sourcing Carbon? Is that like something that changes the timeline for that, or adds any complexity?
Not at all. In fact, it is part of the journey of going open source. And you will learn more about that in the upcoming days as well. Okay, one last question maybe?
During your discussions about memory allocation, there was an idiosyncrasy that was only there on the Mac OS that was then ported over as part of Python 3. When you were using Python 2.7, you talked about changing the interpreter, doing your own modification to the interpreter. Is there any benefit to doing modification to the Python 3 interpreter to remove those behaviors that could potentially speed up memory allocation?
No, there's no need to modify the interpreter. Like actually, in Python 2, we had to modify the interpreter to get our own memory allocation routines into it. With Python 3, there's a clean interface where you just say, when you allocate memory, use these routines. So we were still using sort of the same allocator underneath the hood that we were using in Python 2. And yeah. All right. Thank you very much.